Hi guys, I trust that you're all doing well and fantastic, and that your school year has gotten off to a good start. I know for some of you it's only been a couple of days now since you've been back at school, but nevertheless, I hope that you're making good use of it and then you're enjoying the content so far. And welcome to this lesson on grade 11 mathematics. In this lesson, we're going to have a look at exponents and surds. Now, I've had quite a number of people sending me emails and text messages asking for assistance with these type of questions, and I see in as much as this is one of those topics that you should just go get the marks and run with them. A lot of people still find it confusing. A lot of people still find that they don't know what to do in a setup in which they have a question that deals with exponents, or they're simply just not using the right techniques. So my hope is to be able to clarify this concept for you by the end of this video. And what we're going to have a look at in this video, we're going to look at the introduction to exponents. So the basic concepts that you remember from primary school. We're going to have a look at the laws of exponents. We're going to have a brief run through them, and then we're going to apply them by looking at multiplication and division of powers. Now, addition and subtraction of powers, you will see when we're doing the laws of exponents is not actually, it doesn't form part of the laws. So we need to see now when we add and subtract powers, what do we do? We're going to have a look at rational exponents. We're going to have a look at exponential equations. Then lastly, we'll have a look at the surds, laws of surds, as well as the surd equations. I've placed timestamps in the video description so that you can have a look at each of these sections whenever you want to. You can just skip to them, that you don't have to sit through the whole video and watch everything as I explain it. So please feel free to go to the description and have a look at the timestamps. Click on the specific section that you want so that you don't feel like I'm boring you by holding you hostage. Let's say, for instance, you're looking for the exponential equations, but now you first have to watch me go through everything. You could just go to the description and click on the section for exponential equations, and then you take it from there. Anyways, enough admin, enough said. Let's get started. So, what do we know about exponents? Exponents are a convenient way of writing a number multiplying itself many times. So, for example, if I had to say 2 times 2 times 2 times 2 times 2, you would notice I said 2 5 times. So instead of writing that, repeating the 2 5 times, I could just say 2 to the exponent of 5. So that's why we're saying exponents are a convenient way, or a simple way, for us to write the multiplication process much easier. So here we are again. We said instead of writing 3 times 3 times 3 times 3 times 3, we could just write it 3 to the power 4. I see I included an extra 3 here. Please do bear with me. It's supposed to be 3 to the power 5 because we've got 5 3s here that we're multiplying. So let's look at the definition of exponents. So if we have something like a with a p at the top, well, what we know here is that a is called the base. We've got p, which is called the exponent or the index, and then the whole thing is called the power. Now, I know when we talk sometimes we tend to interchange the exponent and the power, but please take note that there are two different things. The exponent is the little number at the top, and the power consists of everything in that specific term. And as we've said here, a to the power p is the same as saying a times a times a times a. We're multiplying a by itself p times. I hope that this makes sense. This is just the basic concept so that we all understand what exponents are, what their uses are, and what problem it aims to solve. All right, we've got a table here showing the laws of exponents. I know there's a lot of them, but let's just have a look at the common ones that we'll look at, that we'll come across a lot. Like the first one, whenever we multiply numbers of the same base, we add the exponents. Let me quickly go back there. Whenever we multiply numbers of the same base, we add the exponents. You can see there's an example of 2 to the power 3 times 2 to the power 5. Because we've got the same base multiplying, we add the exponents and get 2 to the power 8. If the bases are not the same, this law does not apply. Please take note of this. The law only applies for exponents with the same base. Your question might be, okay, Mr. Brown, you're saying that this law does not apply when working with a different basis. What then do I do if I've got bases which are different? Well, in that case, you just leave the expression as it is because you'll need to use those bases somewhere else. If I'm not making sense, don't worry, we'll do an example where you'll actually see how we go about solving such an equation if it happens that the bases are not the same. All right, so if we divide numbers of the same base, we subtract the exponents. Once again, there's an example right here. Any number to the power 0 is 1. This is a special law, and this is one that a lot of learners confuse for some reason. Any number with an exponent of 0 is 1. Doesn't matter how big the number, doesn't matter how small the number, doesn't matter how negative the number is. If it has an exponent of 0, the answer is 1. We also have 0 to the power a giving us 0. What does this mean? 0 to the power any number is 0. It does not matter how many times I multiply 0 by itself, the answer will still be 0. Now 0 to the power 0 is undefined. Okay, this is just something that you need to know. If we have a negative exponent, we can always take this term and put it as a denominator in the fraction to make the exponent positive. So what are we saying? We're saying if I have a fraction, and the denominator, for example, has a negative exponent, I take the denominator to the numerator to make the exponent positive, and vice versa. And that's exactly what the next law states. If I have a fraction with a negative exponent, I can make that exponent positive by swapping the numerator and the denominator. I hope that this makes sense. Okay, we've got what we call the distributive law of exponents, and what this means is, if I have a power raised to an exponent, I could just multiply the indexes, or I could just multiply the exponents. Also, when I'm multiplying two bases, or when I'm multiplying two powers raised to an exponent, that exponent multiplies every exponent in the bracket. This is quite important. You'll see why in a second. If we divide two powers raised to an exponent, we basically distribute the exponent to every term in the bracket. Now we'll go to the writing page shortly so that we can have a look at what this actually looks like. Just remember that the square root of a is the same as saying a to the power half. So square root is the same as to the power half. And don't worry about this. We'll get into much more details on this specific law when we're looking at surds. I hope that this section makes sense. Let's have a look at the multiplication and division of powers. So, to multiply or divide powers, what do? We need to write each base as a product of its prime factors. If you don't know how to do this, I have a little shortcut that I'll show you on how to do it using a CASIO calculator, but we'll go into that a little later. You need to simplify any exponents wherever applicable. We'll get into that in an example. We add exponents where we've got the same bases multiplied, because remember what we said about the laws of exponents. If we multiply numbers of the same base, we add the exponents. Wherever we've got bases dividing, we subtract the exponents. You write your answers with positive exponents. I know this was a lot said. Let's look at some examples. And so, the first example is 2 to the power n plus 2 times 4 to the power n plus 1 all over 8 to the power n minus 1. Let's go to our writing pad and let's have a look at how we would go about solving such a question. Alright, let me just copy down the question onto the writing pad. So we've got 2 to the power n plus 2 multiplied by 4 to the power n plus 1 divided by, this is a terrible line, divided by, much better, still terrible though, but I can work with it, 8 to the power n minus 1. Alright, so the first thing we need to do is, we need to convert all of our bases to the product of their prime factors. What am I saying? 2 is a prime number. So I'm going to leave this as 2 to the power n plus 2. 4 is not a prime number. We need to write 4 as a prime number. Now the way you would do this on a CASIO calculator, so let me just write the instructions here on the side. So the calculator I'm using is CASIO FX82. Oops, this is terrible. 82 ZA plus. And I believe the newer models, so the FX82 ZA plus 2, also supports this method. So what you would do is, looking at 4, we want to write 4 as a prime number or as a product of its prime numbers. You press 4 equals to. Then you press shift. After pressing shift, you will notice that there's a little button here which looks like it has some degree and inverted commas, and then on top of that button there's the word fact written. So what you do is you press shift and then you press this button. You will get 4 as 2 to the power 2. I'll put this process in the video description so that you can have a look at it and try it out on your own as well. So this is going to be 2 to the power 2 to the power n plus 1 divided by 8 as a prime number is going to be 2 to the power 3 to the power n minus 1. So what do we do here? We just wrote each and every base as a prime number. Our next step is to simplify. So 2 to the power n plus 2, this remains the way it is, multiply by, I need to distribute the exponent in the bracket with the one outside. It's actually the other way around. However, because I've got two terms outside of the bracket, I need to distribute the exponent inside the bracket with the one outside. So this is going to be 2 to the power 2n plus 2. I hope this makes sense. Everything divided by the same story here. 3 times n, that's going to give me 2 to the power 3n. And then 3 times negative 1, that's going to give me negative 3. Okay. Now we will notice on the numerator we are multiplying numbers of the same base. We said when we multiply numbers of the same base we have to add the exponents. So this is going to be 2 to the power n plus 2 plus 2n plus 2 all over, let's put a little bit of a proper line, all over 2 to the power 3n minus 3. So what did we do here? We took, let me use a different color. Because we are multiplying the 2 here and the 2 there, we simply just took their exponents and then we added them. When we multiply numbers of the same base, we add the exponents. So n plus 2n, this is going to give me 2 to the power 3n. Then 2 plus 2, this is going to give me positive 4. All over, this is 2 to the power 3n minus 3. Watch what we're doing here. So in this step, we are dividing numbers with the same base. We said when we divide numbers of the same base, we take the exponents and we subtract them. So this is going to give me 2 to the power 3n plus 4 minus 3n plus 3. Please take a note of the change in the signs here. So 3n minus 3n, that cancels out. We remain with 2 to the power 4 plus 3, that's going to give me 7. You could leave your answer here, or you could press 2 to the power 7 on your calculator, and that's supposed to give you something like 128. I hope that this made sense to you guys, and if for some reason it didn't make sense, please let me know in the comment section so that I can re-upload the video, or if I'm speaking too fast, please just let me know so I could slow down in the next videos that I upload, or re-upload this one if need be. Alright, let's move on to the next question. Alright, we have another very interesting question. 64 to the power n times 16 to the power n minus 1, all over 256 to the power n plus 2. Now please take note, the text in brackets here basically shows where I got the question from. I'm just trying to avoid any copyright issues, but nevertheless, if you check November 2015 paper 1, then you will see where I got number 1 from. So the second question, let's have a look at how we can do this. So back to our writing pad. Let's open up, I'm sure by now you know what I'm going to say, a new sheet of paper, and let's write down the question. So just to have a look at that question again. So there we are. Let's go back to our writing pad. So we've got 64, let's see, to the power n, multiply by 16 to the power n minus 1, divided by 256 to the power n plus 2. Right, once again, we said the first step in answering this question is to make sure that we write all of our bases as prime numbers. So 64 as a prime number, this is going to give me 2 to the power 6 to the power n. Multiply by 16 as a prime number, that's 2 to the power 4 to the power n minus 1. Divided by 256 as a prime number, that should be 2 to the power 8. So here we've got 256 as a prime number. This is 2 to the power 8 to the power of n plus 2. First step complete. We made sure that all of our numbers, our bases, are prime numbers. And the next step, what do we do? I need to multiply out the exponents here. So this is going to give me 2 to the power 6n. Multiply by. Now 2 to the power 4 times n, this is going to give me 2 to the power 4n. Then 4 times minus 1, this is going to give me minus 4. Divided by. This is going to give me 2 to the power 8 times n, this is 2 to the power 8n. Then 8 times 2, this is going to give me positive 16. So, moving right along, on top we are multiplying numbers of the same base. We said since we are multiplying the 2's, we have to take the exponents and add them. So, this is 2 to the power 6n plus 4n minus 4 divided by, this is 2 to the power 8n plus 16. Now notice, this time around we are dividing numbers of the same base. Well, before I get there, let me just simplify my exponents. So this is 2 to the power 6n plus 4n, this is 10n, minus 4, divided by, this is just 2 to the power 8n plus 16. Notice, we are dividing numbers with the same base. We have to take the exponents and subtract them. So, this is going to give me 2 to the power 10n minus 4 minus 8n minus 16. This is going to give me 10n minus 8n, that's 2 to the power 2n, minus 4 minus 16 is going to give me minus 20. I can leave my answer like that. It's complete. Life is great. I hope you guys are enjoying this and I hope it's making sense. Please do give us a thumbs up. Please subscribe to the channel so that you can get an update every time when I upload new videos. Turn on the notifications and please share this so that everybody else can benefit from the knowledge that we're sharing here. Alright, let's move on to the next question. Here's an interesting one. There seems to be a lot going on here, but anyways, let's write it down and let's digest it step by step. So, new sheet of paper, there we are. Let's copy down the question. So we've got 81 to the power k. Let's see. Times 27 to the power negative k plus 1 multiply by 9 to the power k minus 3. Let me use a straight line to draw the division sign. There we are. Straight line is great. So next we have a third raised to the power negative 2k times 9 raised to the power minus k plus 1. Alright, we said the first step that we need to make sure of is that every number that we have, every base that we have is written as a prime number. 81 is not a prime number, but 81 as a prime number is 3 to the power 4 to the power k. Multiply by 27 is a prime number. This is 3 to the power 3 to the power minus k plus 1. Multiply by 9 is a prime number. This is 3 to the power 2 to the power k minus 3. Let's draw a straight line division sign again. 1 over 3, I can write this as 3 to the power minus 1. Now you might be asking yourself, why am I writing it like this? Well, first of all, we've got bases of 3 at the top. So why don't we just take this 1 over 3 and write it as a base of 3? Next, 9 can be written as 3 squared to the power minus k plus 1. Our first step is complete. We've written all of our bases as prime numbers. The next step is to multiply out the exponents. This is 3 to the power 4k. Okay, that's terrible. There's 4k. Multiply by 3 times negative k. This is going to give you 3 to the power negative 3k. 3 times 1. This is going to give you positive 3. Multiply by 2 times k. This is 3 to the power 2k. 2 times minus 3. This is minus 6. Let's get a straight line division again. Not bad, not good either. We could do better than this. Right, then negative 1 times negative 2. This is going to give me 3 to the power positive 2k. Multiply by 2 times negative k. This is 3 to the power negative 2k. And then 2 times positive 1. This is just going to give you positive 2. All right, we are done multiplying out our exponents. Let's just get some space here. Now for the next step. You will notice that we are multiplying numbers with the same base. We've got base of 3, base of 3, base of 3. When we multiply numbers of the same base, we add the exponents. So let's add the exponents. 3 to the power 4k minus 3k plus 3 plus 2k minus 6. Right. All of this divided by. Notice at the bottom on the denominator, we are also multiplying numbers of the same base. So we have to take our exponents and add them. I hope the use of color here is assisting you guys in understanding exactly how we go about doing the process. So this is going to be 3 to the power 2k minus 2k plus 2. Right, now we simplify. 4k minus 3k, that's going to give me positive k. Positive k plus 2k, that's going to give me 3 to the power 3k. 3 plus minus 6, that's just going to give me minus 3. Divided by 2k minus 2k, this is going to cancel out. We remain with 3 to the power 2. Now, once again, as we said, we are dividing numbers of the same base. Whenever we divide numbers of the same base, we take the exponents and subtract them. So this is going to be equals to 3 to the power 3k minus 3 minus 2. This is just going to give you 3 to the power 3k minus 5. And this is your final answer. Life is great. I hope it makes sense to you guys, and I hope that you're understanding and still enjoying the content. Right, let's go back to our notes. Okay, now we move to an interesting subject, the addition and subtraction of powers. Whenever we add or subtract powers, you will remember that there is no law that tells us how to add or subtract powers. To prove it, let's go back to our table with the laws of exponents. There's nothing, absolutely nothing telling us what do we do to the bases or the exponents when we add powers. We know that when we multiply powers, we have to add the exponents. When we divide powers, we have to subtract the exponents. What happens if we add powers? What happens if we subtract powers? And that's what we're looking at right now. So whenever you are adding or subtracting powers, you need to write each base as a product of its prime factors. This is quite important. The next step is you need to write each exponent with its own base. I'll show you what I mean by that in a second. Then you need to factorize the expression. Now, I wrote this in bold because your methods of factorization that you learned in grade 10 are still coming into play now. You still need to know how to do the common factor. You still need to know your difference of two squares, your perfect square trinomial. It's still going to be assessed here. Lastly, you simplify the resulting expression. Write your answers with positive exponents. All right, let's look at an example. So there we have an interesting question, and notice that on the numerator there's subtraction of powers. Now we need to do something great and interesting. First thing, new sheet of paper. Next, copy down the question. So my question says 3 to the power x plus 1 minus 3 to the power x minus 1 divided by 2 multiplied by 3 to the power x. Now the first thing that we said in our notes is, if we could just go back. Okay, just give me a moment. My system is a bit slow today. Please bear with me. If we go back to our notes, we said that when we are multiplying and subtracting, when we're adding and subtracting powers, we need to write each base as a product of its prime factors. Now, when we go back to our expression, we already have prime factors here. So let's look at the next step. Next step says we need to write each exponent with its own base. Let's have a look at this. You will notice that my two terms at the top, 3 to the power x plus 1 and 3 to the power x minus 1, they've got more than one term. The exponents have more than one term. We've got two terms here, we've got two terms there. So what we need to do is we need to write each of the terms in the exponent with their own base. This is going to be 3 to the power x multiplied by 3 to the power 1. This is how we separate the exponents to have their own base. Minus 3 to the power x multiplied by 3 to the power negative 1. Right, what we have at the bottom does not change. We're still going to have the same expression because there's no addition or subtraction taking place here. So we are still going to have 2 times 3 to the power x. So let's see what happens. Let's quickly go back to the notes so that we can see what is the next step after writing each exponent with its own base. We need to factorize the expression. What type of factorization can we use here? Let's see. I can see 3 to the power x. I can see 3 to the power x. I'm thinking common factor. So my common factor is going to be 3 to the power x. Then if I take out the common factor from the first term, I remain with 3 to the power 1. If I take out the common factor from the second term, I remain with 3 to the power negative 1. All over 2 times 3 to the power x. Now, at this point, you will see that your 3 to the power x and 3 to the power x cancels out. Now we can simplify our expression. 3 to the power 1 is 3. 3 to the power minus 1 is 1 over 3 divided by 2. So let's simplify this. So 3 minus 1 over 3, that's going to give you 8 over 3 divided by 2. And I do not like how this is looking like, so I'm just going to write it as 8 over 3 divided by 2, which is the same as saying 8 over 3 multiplied by 1 over 2, and this is just going to give me 4 over 3 as an answer, and there we are, we are done. Life is great. Notice that your exponents of the bases are positive, so you're good to go. I hope that this one made sense to you guys. All right, let's look at the next question. So there's our second question. Let's copy this down. So once again, new sheet of paper. We have got 4 to the power x minus 1 plus 4 to the power x plus 1 all over 17 times 12 to to the power x. Okay, we said our first step is to make sure that we write the bases as prime numbers. 4 as a prime number is 2 to the power 2 to the power x minus 1 plus 4 as a prime number, 2 to the power 2 to the power x plus 1 divided by, this is 17 as a prime number is just 17. We can't simplify that. Now 12 as a prime number, that's going to give you, this is 2 to the power 2 times 3 to the power x. Right, we are done writing our bases as prime numbers. Now we need to multiply out our exponents. So 2 times x, this is 2x. 2 times minus 1, this is minus 2, plus 2 times x, this gives me 2x. 2 times 1, this gives me positive 2. All over, this is 17 times. Now, when I have a setup like the one I have here, I'm going to say 2 times x, and that's going to give me 2 to the power 2x. Now, the exponent of 3 is 1 here, so I'm going to say 1 times x. This is going to give me 3 to the power x. All right, we are done multiplying out the exponents. The next step is, notice the plus sign here. The plus sign is telling me I need to write each base with its own exponent. So 2 to the power 2x, multiply by 2 to the power minus 2, plus 2 to the power 2x, multiply by 2 to the power 2. All of this divided by, let's see, at the bottom nothing is changed. We've got 17 times 2 to the power 2x times 3 to the power x. Right, our next step is we need to factorize. I see there's 2 to the power 2x and 2 to the power 2x. Aha, we've got a common factor. So let me take out the common factor of 2 to the power 2x. I will then remain with 2 to the power minus 2 plus 2 to the power 2. Let's just draw a straight line here. This is all over 17 times 2 to the power 2x times 3 to the power x. 2 to the power 2x and 2 to the power 2x cancels out. Let's see what we remain with. So we're going to remain with 2 to the power minus 2 plus 2 to the power 2. Let's bring back our division line. This is all over 17 times 3 to the power x. Now we can simplify this. Let me just get some space. This is going to be 1 over 4 plus 4 divided by 17 times 3 to the power x. If we write this like this, we're going to have 17 over 4 divided by 17 times 3 to the power x. Once again, I hate how this looks like. So I'm going to write it as 17 over 4 multiply by 1 over 17 times 3 to the power x. The 17 and the 17 cancels out. My final answer is 1 over 4 times 3 to the power x. My exponents are positive, so I'm good to go. If it happened that I had a negative exponent, let's say I had, for argument's sake, 3 to the power minus x. I would have taken this to the top so that it becomes 3 to the power positive x. Because remember, when working with exponents, your answers should always have positive exponents. Please keep this in mind. Let's look at the next question. So, we have here, let's just go back to our writing pad, and let's copy down the question. So, we have 3 to the power m plus 4, let's see, minus 6 times 3 to the power m plus 1 divided by, terrible division line. Let's get a straight line going here. So all divided by 7, So this is 7 times 3 to the power of m plus 2. Now once again, you will notice that right here at the top, on my numerator, there's a minus sign. The minus sign is giving me an indication that I need to separate the exponents. Remember what we said. Whenever we see a plus or a minus, this is an indication that we need to separate the exponents. So we are going to have here 3 to the power m multiplied by 3 to the power 4 minus 6 times 3 to the power m multiplied by 3 to the power 1 all over, this is going to be 7 times 3 to the power m times 3 to the power 2. Now you might be asking yourself, why don't we take the 6 and make it a prime number? You could if you want to, but what I'm interested in here is I only want to make the bases prime numbers. In other words, the 3 with an exponent of m has to be a prime number. The 3 with the exponent of m has to be a prime number. So if 6, for example, let's just say for argument's sake, 6 had an exponent of m, then I was going to make this a prime number. But since we do not have an exponent of m, I'm just going to leave it as is. What you will notice is that on your numerator, there's a common factor. We've got 3 to the power m, 3 to the power m. So we could take out the common factor. We remain here with 3 to the power 4 minus 6 times 3. Please take note of this. We have removed our common factor of 3 to the power m, so we remain with 6 times 3. All over, this is going to be 7 times 3 to the power m times 3 to the power 2. If you look at this, you will notice there's a common factor. 3 to the power m and 3 to the power m cancels out. So we're going to remain here with 3 to the power 4 minus 6 times 3 divided by 7 times 3 to the power 2. You can go ahead and write this out on your calculator. You'll have something like 81 minus 18 divided by, oops, that's a terrible division line, divided by 7 times 3 squared, that's going to give you 63. So now when you have your expression like this, it would be easy for you to see that 81 minus 18, that's going to give you 63. So this is going to be 63 divided by 63, which is going to give us 1. And that's our final answer. Life is great. I hope that this makes sense to you guys. Once again, if you're enjoying the video, please give us a thumbs up. Please subscribe to the channel so that you'll have updates every time when we upload some new content. Alright, lastly, we have this question. So let's go back to our writing pad and let's write this out. So let's just get a new sheet of paper going here. We've got 3 to the power 2x minus 12 times 3 to the power x plus 27. Let's see what we can do here. Well, first of all, I can see I've got 3 to the power x here. So let me see if I can write 3 to the power 2x as 3 to the power x. This is going to give me 3 to the power x squared minus 12 times 3 to the power x plus 27. If you get to this point, you will notice that we've got 3 to the power x here, we've got 3 to the power x here. To simplify my life, I'm going to assign a variable. Let's call it m, and we're going to set this equals to 3 to the power x. So let's see. This is going to be m squared minus 12m plus 27. Now you can see this is a trinomial. So what we could simply do is we could factorize the trinomial. We've got m here, we've got m here. Last term is positive, so my 2 signs inside the bracket should be the same. Because the middle term is negative, I'm going to have 2 minus signs. Factors of 27, I'm going to have 9 and I'm going to have 3. But now you will remember that in the expression we've got 3 to the power x, we don't have m. So I'm going to go back into the brackets and I'm going to substitute 3 to the power x where I see m. This is going to be 3 to the power x minus 3. And there we are done. So one note that you should always keep in mind is, when you see a plus or a minus in between powers, this is telling you factorize. But before you can factorize, what you need to remember is that you need to split the exponents. So what are we saying? You need to make each exponent to have its own base. Then you can factorize. Whenever we've got multiplication or division, this is telling us that we need to write our bases as prime factors. In fact, even if you have a plus or minus, you still have to get prime factors. Then what you need to do is you need to just simplify using the laws of exponents. So we are saying wherever we have numbers of the same base which are multiplying, add the exponents. Where we have numbers of the same base numbers of the same base dividing, that's where we subtract the exponents. I hope that the distinction makes sense. So let's move on. Now we're going to have a look at rational exponents. If you can remember from grade 10, a rational number is any number that can be written as a fraction. So in essence, we are saying that rational exponents are exponents that can be written in the form a over b. In other words, they can be written as fractions. Here we've got some examples of rational exponents. So we've got x to the power 2 over 3, y to the power 5 over 4, 16 to the power 3 over 4, and in each of these cases you will notice that the exponent is a fraction. The exponent is a rational number. So let's look at some examples of how we would go about working with rational exponents. We are asked to simplify 8 to the power 2 over 3. So let's have a look at this. Let me scroll down. We are simplifying 8 to the power 2 over 3. Now the first thing that you need to keep in mind here is that you must write your base as a prime number. This is going to be 2 to the power 3 to the power 2 over 3. Then you will remember from laws of exponents that when we have a setup like this, we could simply multiply the exponent outside of the bracket with the exponent inside of the bracket. The 3's will cancel out. You remain with 2 to the power 2, which is just going to give you 4. There we are. We have simplified the rational exponent here. Right, let's look at another one. Here's an interesting one. 27x to the power 6, y to the power 12. Please take note, there's a little bit of a typing error here. This is supposed to be y to the power 12, not y to the power 1, 2. So let's have a look at how we would do this. So we have 27x to the power 6, y to the power 12, all to the power 1 over 3. So once again, the first thing that we need to do, as we've been doing, is we need to write 27 as a prime number. This is going to be 3 to the power 3. You know what? Let me write this on a new line. So this is going to be 3 to the power 3. This is x to the power 6, y to the power 12, to the power 1 over 3. When we get to this point, as we have mentioned earlier with the laws of exponents, we need to multiply the exponent outside of the bracket with every exponent inside of the bracket. So this is going to give me 3 to the power 3 multiplied by 1 over 3. X to the power 6 multiplied by 1 over 3. Y to the power 12 multiplied by 1 over 3. I hope that this makes sense. Now when we simplify this, 3 times a third, that's just going to give you 3 to the power 1. X to the power 6 times 1 over 3, so 6 times 1 over 3, that's just going to give you x to the power 2. 12 times 1 over 3, this is going to give us y to the power 4. And this would be our final answer. Lovely. Wonderful. Life is great. Alright, then we have another interesting question here. 81k to the power 16p to the power minus 4 over 16q to the power 8, all to the power 3 over 4. Let's get this down on our writing pad. So I think now would be a good time for a new sheet of paper. Let's put 81. Let's see, what do we have here? So this is 81 k to the power 16 p to the power negative 4 all over 16 q to the power 8 all to the power 3 over 4. So the first thing we need to do is let's write all of our bases as prime numbers. 81 is 3 to the power 4. This is just k to the power 16, p to the power minus 4, divided by 16 as a prime number is 2 to the power 4, q to the power 8, all raised to the power 3 over 4. The next step is to multiply the exponent outside of the bracket with the exponent inside of the bracket, even with the ones at the denominator. So this is 3 to the power 4 multiplied by 3 over 4. This is k to the power 16 multiplied by 3 over 4. This is p to the power negative 4 multiplied by 3 over 4. And this is all divided by. So 2 to the power 4 multiplied by 3 over 4. Q to the power 8 multiplied by 3 over 4. After getting to this point, we now need to go ahead and simplify our exponents. So the 4 and the 4 will cancel. We remain with 3 to the power 3. 4 goes into 16 4 times. 4 times 3, that's going to give us k to the power 12. The 4 and the 4 cancels here. We remain with p to the power negative 3. And this is all divided by, whoops, that's a terrible division line. This is all divided by 2 to the power, 4 and 4 cancels, we remain with 3. 4 goes into 8 twice. 2 times 3, that's going to give you q to the power 6. Now we have a negative exponent in this expression. We heard earlier, or we saw earlier, that we always need to write our answers with positive exponents. So to make p to the power negative 3 a positive exponent, I'm going to take it down to the bottom. I'm going to take it down to the denominator. So this is going to be 3 to the power 3, k to the power 12, and this is all going to be divided by, we've got 2 to the power 3, p to the power 3, q to the power 6. There we have it. We are done. Let's move on to the next section. So now we're looking at exponential equations. With all of the laws that we've looked at so far, the rational exponents, your multiplication of exponents and division of bases, addition and subtraction of powers, now it's time to put everything into practical use by actually solving some equations. So here's the first equation. We've got the the xth root of 9 is equals to 243. Let's go to the writing pad and let's attempt this question. So, whoops, if my pen could come back to life. We've got the xth root of 9, which is equals to 243. The first thing we do here is to write every base as a prime number. This is going to be the xth root of 3 to the power 2 is equals to 243 as a prime number. That is supposed to give you 3 to the power 5. We are done with the first part. Now we have a little bit of a problem here, which is not really a problem, but nevertheless. We have the xth root. We can write this in exponential form by saying this is 3 to the power 2 divided by x. This is equals to 3 to the power 5. The bases are the same. Let's drop the exponents. Let's equate the exponents. 2 over x is equals to 5. You could say this is 5 over 1. Now we can go ahead and solve for x by cross multiplying. So I'm going to get 5x is equals to 2. Divide the side by 2, divide the side, we're supposed to divide by 5. And divide the side by 5, so that we get x is equals to 2 over 5, and we are done solving the equation. Life is great. Let's have a look at the next question. So, in our next question, we've got something interesting going on. 4 to the power x plus 8 equals 9 times 2 to the power x. Let's have a look at that one. So, first of all, let's get a new sheet of paper, and let's copy down the equation. So we've got 4 to the power x plus 8 is equals to 9 times 2 to the power x. As we've mentioned, we need to take the 4 and make it a prime number. 4 as a prime number is 2 to the power 2 to the power x plus 8 is equals to 9 times 2 to the power x. Now I'm going to take everything to the right hand side, to the left hand side. This is 2 to the power 2x minus 9 times 2 to the power x plus 8 is equals to 0. Now when I'm at this point, I'm going to rewrite 2 to the power 2x as 2 to the power x squared minus 9 times 2 to the power x plus 8 is equals to 0. Once again, I can use some substitution. Let me assign a variable k equals to 2 to the power x. This is going to give us k squared minus 9k plus 8 is equals to 0. At this point, we can go ahead and factorize. So we've got two brackets. This is k, this is k. Last term is positive, so we've got the same signs in the brackets. Because the middle term is negative, I will have two negative signs. Factors of 8, I can use 8 and 1. I will then have k is equals to 8 or k is equals to 1. But remember what we said, k is 2 to the power x. So I'm going to say here 2 to the power x is equals to 8 and 2 to the power x is equals to 1. Let's simplify. So 2 to the power x is equals to 2 to the power 3. 2 to the power x, remember we said any number to the power 0 is 1. Let me use a base of 2 here to the power 0 so that I've got the same basis. Now that I've got the same basis on both sides, x is going to be equals to 3 or x is equals to 0. And there we are, we have solved the equation. Wonderful. Moving on to the next question. Alright, now we've got a rational exponent. X to the power negative 3 over 4 is equals to 8. Let's get to it. So, new sheet. X to the power negative 3 over 4 is equals to 8. When you're solving a rational exponent, just like with any other question, we first have to make sure that our numbers are written as prime numbers. This is 2 to the power 3. Now take note of something. The exponent is negative 3 over 4. What I need to do is I need to raise this to negative 4 over 3. Why? Because I want to remain with x having an exponent of only 1. So what did I do here? Take the negative sign as it is, multiply by the inverse of the fraction, so that the 4 and the 4 cancels, the 3 and the 3 cancels. But now we know what we do on the left, we do on the right. So I'm going to raise this to the same negative 4 over 3. By so doing, you will notice that 3 and 3 cancels. You remain with 2 to the power negative 4, which is going to give you 1 over 16. So x is 1 over 16. There we are, we've solved the equation. Perfect. Right, the next question is pretty similar to the one that we did in number 2, but let's have a look at it. So, let's get some room here. We have got 4 to the power x minus 2 to the power x is equals to 2. So let's start by writing 4 as a prime number. This is 2 to the power 2 to the power x. Minus 2 to the power x. I'm going to take the minus 2 to the other side. This is equals to 0. Once again, let me rewrite this as 2 to the power x squared minus 2 to the power x minus 2 is equals to 0. I can now assign a variable. I can say something like let p equals to 2 to the power x. Wonderful. I'm going to have p squared minus p minus 2 is equals to 0. We can factorize this. If I factorize this, I am going to have this is p, this is p. We know that the last term is negative, so the signs must be different. Because the middle term is negative, the biggest factor of the last term takes the sign of the middle term. This is 2, this is 1. We're going to get p is equals to negative 1, p is equals to 2. But remember, we were not solving for p, we were solving for 2 to the power x, we're solving for x. So 2 to the power x is equals to negative 1, and 2 to the power x is equals to 2. In the first example, because we have a negative and a positive sign, the bases do not have the same sign, so x will be undefined here. When we look at the second example, we know that this is 2 to the power 1, so x is going to be equals to 1. Wonderful. Alright, and then there's one last question. 2 to the power 3x plus 1 plus 2 to the power 3x equals 12. So let's look at this one. So we have got 2 to the power 3x plus 1 plus 2 to the power 3x is equals to 12. Notice that there's a plus here. Remember what we said when adding powers or subtracting powers. The plus or minus always tells us that we need to separate the exponents. So this is going to be 2 to the power 3x times 2 to the power 1 plus 2 to the power 3x is equals to 12. I see a common factor. My common factor is 2 to the power 3x. I remain with 2 plus 1 is equals to 12. Now 2 plus 1, this is simply going to give me 3. This is equals to 12. I can divide both sides by 3. And I remain with 2 to the power 3x is equals to 4. Now we can also write 4 as a prime number. So 2 to the power 3x is equals to 2 to the power 2. Bases are the same, let's drop the exponents. 3x is equals to 2 divided by 3 divided by 3. We get x is equals to 2 over 3. And there we are. The question is solved. I hope that this makes sense. Don't forget to hit that subscribe button. Click on the bell icon so that you can get notifications every time when we upload some new videos. Okay, now we move on to surds. So surds are numbers that can be expressed with the radical sign. Now most of us think about this sign as the square root. We think about the sign to say, okay, this is the square root sign, and that's correct. But now what would happen if we had a number just above the sign? Then you would realize that it's no longer square root, it could be cube root. That's why we refer to it as the radical sign. To simplify surds, you always need to make sure that the numbers under the radical sign are written as prime numbers, prime factors. You see, it's the same thing that we've been working with from exponents that we are applying here. In fact, you can think of exponents and surds as cousins. We've got laws of surds. And this is very similar to the laws of exponents, where if we have the square root of a, that's a to the power half, the cube root of a is a to the power 1 over 3, the nth root of a to the power m is a to the power m divided by m. Notice that if we are multiplying two numbers under the root sign, we could distribute the root sign to each of those two numbers. When we divide numbers under the same root sign, we could distribute the root sign to each of the numbers. This does not apply to addition and subtraction though. Please take note of it. Alright, let's look at some examples of surds. And let's get our hands dirty so that we can understand the concept. So we need to simplify this expression. Let's go to our writing pad. So we have got the square root of 20 into the square root of 3,125. Let's see. Minus the square root of 20. So what we can do here is, we said we first need to write every term under the radical sign as a prime number. So 20 is a prime number. Whoops. I could say 20 is 2 to the power 2 times 5. We open a bracket. Now 3,125, if you try and work out the prime factors of that, you are going to get something like the square root of 5 to the power 5. Minus the square root of, we've got 20 again, so 2 to the power 2 times 5, like that. Notice that we've got times 5 here, we've got times 5 there. So in a way, what I will need to do then is I'll need to rewrite this 5 to the power 5 so that we have something times 5, just for consistency. This is 2 to the power 2 times 5. This is going to be the same as 5 to the power 4 times 5. Remember from laws of exponents, if I multiply numbers of the same base, I add the exponent. So 5 to the power 4 times 5 to the power 1. 4 plus 1 will still give us the 5. Minus the square root of 2 to the power 2 times 5. When we simplify this, we need to now remember what we said. Let's just go back to the notes quickly. When we looked at the laws of surds, we said when we are multiplying numbers under the radical sign, we could distribute the radical sign to each of the numbers underneath the radical sign. And that's exactly what I'm going to do now. So we are going to split this. This is going to be the square root of 2 to the power 2 multiplied by the square root of 5. Inside the brackets, the square root of 5 to the power 4 multiplied by the square root of 5 minus the square root of 2 to the power 2 multiplied by the square root of 5. Wonderful. So now, the square root of 2 to the power 2, we can write this as 2 to the power 2 over 2 times, I'm going to leave the square root of 5 as it is. Then the square root of 5 to the power 4. This is 5 to the power 4 divided by 2. If you can remember from your laws of exponents, square root is power half. That's why we've got the denominator of 2. Times the square root of 5 minus, this is 2 to the power 2 over 2 times the square root of 5. Wonderful. When we simplify this, we're going to get 2 times the square root of 5 into 5 to the power 2 times the square root of 5 minus 2 times the square root of 5. Let's simplify the 5 to the power 2. I can write this as 2 root of 5 into 5 squared is going to give me 25 square root of 2. Sorry, this is square root of 5 minus 2 square root of 5. Now, inside of the brackets, I've got like terms. You can think of this as being 25x, and this is minus 2x. 25x minus 2x, we know this is going to give us 23x. So how do we identify like terms in surd form? Whenever we've got the same radical sign, So in this case, we've got square roots on both sides, and we've got the same number underneath those radical signs. Then those are like terms. So I can say this is 2 square root of 5 into 25 minus 2 will give me 23 square root of 5. Now, this is how we multiply. We're going to say 2 times 23 multiply by square root of 5 times the square root of 5. This is going to give us 2 times 23, that's 46. The square root of 5 times the square root of 5 just gives us 5. So now we have 46 multiplied by 5. This is going to give us an answer of 230. And we're done simplifying the expression. Awesome. Let's go to our next question. So we've got the square root of 27 minus the square root of 12 divided by the square root of 3. Let's go to our writing pad. And let's attempt this question. So we have got the square root of 27 minus the square root of 12 divided by the square root of 3. So if we want to get the square root of 27, or if we want to get 27 as a prime number, your calculator will give it to you as 3 to the power 3. I'm going to write this as 3 to the power 2 times 3 minus the square root of 12. 12 is going to be 2 to the power 2 times 3 all over the square root of 3. Because 3 is already a prime number, this is just going to be the square root of 3. Next, we can now distribute and split our radical sign. So square root of 3 to the power 2 times the square root of 3 minus the square root of 2 to the power 2 times the square root of 3. All of this divided by the square root of 3 is just the square root of 3. If we simplify this, we're going to get 3, the square root of 3 squared, that's just going to give us 3 as we saw in the previous example, times square root of 3 minus the square root of 2 squared is 2 times the square root of 3 divided by the square root of 3. Once again, we have like terms. 3x minus 2x, we know this is just x. So in the context of the surds we're looking at right now, this is going to give me the square root of 3 divided by the square root of 3, giving me an answer of 1. I hope that this made sense. Let's have a look at the next question. Alright, we've got something interesting going on here. Let's copy down the question. So let's get a new sheet of paper. This time around, we have got the cube root of 54x to the power 15. Notice it's cube root, no longer square root. Plus the cube root of 2x to the power 15, all divided by the cube root of 16x to the power 15 minus the cube root of 250x to the power 15. I know it looks complicated at first, but we just need to stick to what we've been doing. And the first step we said is to write our bases as prime numbers. So 54 as a prime number, this is going to give me 2 times 3 to the power 3. Then this is x to the power 15 plus, whoops, that was terrible. Let's try this again. Much better. 2 is already a prime number, so I'm just going to leave this as 2x to the power 15. All divided by the cube root of 16. I'm going to write this as, when you press 16 on the calculator to get a prime number, you will get 2 to the power 4. I'm going to write this as 2 to the power 3 times 3, x to the power 15, minus Whoops. I am terrible at writing these cube roots. So 250 as a prime number, this is going to give us 2 times 5 cubed, x to the power 15. Wonderful. The next step is to distribute our radical sign. This is cube root of 2 times cube root of 3 to the power 3 times cube root of x to the power 15 plus cube root of 2 times cube root of x to the power 15. And this is all divided by. This is going to be the cube root of 2 to the power 3 times the cube root of 3 times the cube root of x to the power 15 minus the cube root of 2 times the cube root of 5 cubed times the cube root of x to the power 15. I know there's a lot going on here, but let's see. The cube root of 2, I'm going to leave this as the cube root of 2 times. The cube root of 3 to the power 3 will give me 3. The cube root of x to the power 15 is x to the power 15 divided by 3. Plus, 2 is already a prime number, this I leave as it is, times x to the power 15 over 3. All of this divided by the cube root of 2 to the power 3 is just 2 times the cube root of 3 times x to the power 15 divided by 3 minus the cube root of 2 is just the cube root of 2 times x to the power 15 divided by 3. Let's simplify this. So 15 divided by 3 gives us 5. So we've got 3x to the power 5 cube root of 2 plus the cube root of 2x to the power 5 all divided by, we have got, this is just going to be 2, this is just going to be 2 cube root of 3 x to the power 5 minus the cube root of 2x to the power 5. Right. Notice that on my numerator I've got a common factor. In fact, I've got like terms. 3x to the power 5 with the cube root of 2, x to the power 5 with the cube root of 2. 3x to the power 5 minus x to the power 5 will give me 2x to the power 5 cube root of 2. And this is all going to be over. Take note that on my denominator, the only common factor I have is x to the power 5. So I could just take out x to the power 5 as my common factor, because notice here we've got the cube root of 3, we've got the cube root of 2, we can't do anything to them. So I'm just going to leave this as 2 cube root of 3 minus cube root of 2. The x to the power 5 and the x to the power 5 will cancel out. And this is going to give us the cube root of 2. This is 2 cube root of 2 all over 2 cube root of 3 minus the cube root of 2. There we are. Question is done. Wonderful. Let's move on to the next section. Now, in our last section for this lesson, we're going to have a look at surd equations. Now, surd equations are the type of equations where you've got a variable being under the radical sign, and usually that radical sign would be a square root. In order for you to be able to solve for this type of equation, you need to apply an exponent to remove the radical sign on both sides of the equal sign. What do I mean by this? If we have a square root, you need to square both sides because the square root and the square cancel each other out. If we have a cube root, you need to cube both sides because the cube and the cube root cancel each other. If we have an 8th root, we raise both sides to the power 8. I think you get the basic idea. Let's look at a couple of examples. So, here's our first example where we're solving for x. Let's go to the writing board and let's attempt this question. So, we have the cube root of 5 minus x is equals to x minus 1. When solving such type of equations, notice we've got a square root. So what I need to do in order to simplify this is I need to square both sides because I want to get rid of the square root. So when I square both sides, on the left I'm going to remain with 5 minus x. On the right, this is going to be x minus 1 into x minus 1. So 5 minus x is going to give me x squared minus x plus 1. 5 minus x is going to be x squared minus 2x plus 1. Let's take everything to the right hand side. So 0 is equals to x squared minus 2x plus 1 plus x minus 5. And so 0 is going to be equals to x squared negative 2x plus x, that's going to give us negative x. 1 minus 5, this is going to give us negative 4. Right. In this instance, we cannot really factorize this. So what we're going to have to do is we need to use the quadratic equation to solve for x. So I know that the value of a is equals to 1, the value of b is negative 1, the value of c is negative 4. Using my quadratic equation, x is going to be negative b plus or minus the square root of b squared minus 4ac, and this is going to be all over 2a. So this is going to give me negative 1 plus or minus the square root of, this is 1 squared, negative 1 squared, minus 4 into the value of a is 1, the value of c is minus 4. And this is all over 2 times 1. So we have x is equals to positive 1 plus the square root of 1 plus 16 divided by 2. Or we have x is equals to 1 minus the square root of 1 plus 16 all over 2. This is going to give you x is 1 plus the square root of 17 over 2. You're also going to have x is equals to 1 minus the square root of 17 over 2. You can press this on your calculator and get the final answer. Wonderful. And so for the next equation, we've got an interesting one here. We've got the square root of x minus 2 to the power negative 3 is equals to 64. Let's go to the writing pad and have a look at this. So, new sheet of paper. The square root of x minus 2 to the power minus 3 is equals to 64. So first things first, how's about I write this first part in exponential form? This is going to be x minus 2 to the power minus 3 over 2. 64 as a prime number is going to be 2 to the power 6. I can raise both sides to the power negative 2 over 3. Raise this to the power minus 2 over 3. So what we're going to be left with here is x minus 2 is equals to, let's see, 3 goes into 6 twice. 2 times minus 2 is 2 to the power minus 4. So x minus 2 is equals to 1 over 16. X is equals to 1 over 16 plus 2. This is going to give you something like 33 over 16 for the value of x. I hope that this makes sense. If you didn't want to do it this way, what you could have done is, you could say, okay, we've got the square root of x minus 2 raised to the power minus 3. This is equals to 64. You could decide to square both sides so as to get rid of the square root sign. You will then remain with x minus 2 to the power minus 3 is equals to, and 64 squared is supposed to give you, if my pen could come back to life, 4096. Then you can raise this side to the power negative 1 over 3, raise this side to the power negative 1 over 3, so that we remain with x minus 2 is equals to, then 4096 raised to the power negative 1 over 3 is going to give us exactly the same thing we had, which is 1 over 16. You can then take the negative 2 to the other side. You remain with x is equals to 1 over 16 plus 2. And you still get your answer is 33 over 16 for the value of x. I hope that this made sense to you guys. Let's look at our, I believe it's the last question for this section. Yes. So 2x plus 1 equals x minus 1. Let's have a look at this. Let's just get a new sheet of paper going here. Square root of 2x plus 1 is equals to x minus 1. The first thing we do is we square both sides. We will remain with 2x plus 1 is equals to, if I simplify this, I'm going to get x squared minus 2x plus 1. 0 is equals to, let's take everything to the other side. X squared minus 2x plus 1 minus 2x minus 1. We will remain with 0 is equals to x squared minus 4x. Now we can factorize this by taking out a common factor. So this is x minus 4. We are going to have x is equals to 0. X minus 4 is equals to 0. Then we get x is equals to 4. Wonderful. I hope that this lesson made sense to you guys, and I trust that now you understand the concept of exponents much better. I do hope that you enjoyed the lesson, and I shall see you guys in the next one. In the meantime, please don't forget to like, comment, subscribe, and turn on the notifications, and most importantly, also share this video with others so that they can benefit from the same knowledge that you're benefiting from now. Until then, until next time, see you guys, take care of yourselves, ciao.